Good morning to all. In this video, I am going to solve two problems based on the topic network elements. We know the network elements are the resistor, inductor and capacitor. So these problems are based on the resistance network. Okay, this is the problem number 1, which is given in GATE 2016 EEE. It is given for 1 marks. It is given in the set 1. So what is the problem? RA and RB are the input resistance of circuits as shown below here. The circuits extend indefinitely in the direction shown. Which one of the following statements is true? So here two networks are given. So observe the network, and here this is the network which consists of 2 ohms and 1 ohms. Here also 2 ohms and 1 ohms. Here also 2 ohms and 1 ohms. So observe the second network. Observe the first network. So here 4 options are given for the relationship between RA and RB. So if RA is the resistance, equivalent resistance of the first network, we have to find RB with respect to RA. So see the difference between this network. So just 1 ohms, this 1 ohms is the additional resistance branch compared to RA network. Okay, if RA is the equivalent resistance of this network means, so this is the network which has the equivalent resistance RA. So if RA is the equivalent resistance means, in parallel with 1 ohms, this is RA. So this 1 ohms is the extra resistance that is in parallel. So we can find RB is the equivalent resistance of this network. So RA in parallel with RB means, RA in parallel with 1 ohms means RB equal to 1 into RA, that is RA, by 1 plus RA. So here observe the options. Option D is correct. RB equal to RA by 1 plus RA. So we can directly find out by observing the two networks. We have to find the difference, and then we have to find the equivalent, a relationship between RB and RA. That's all. And we will see the next problem. This is the problem number 2, which is given in GATE 2017, which is given for 1 marks. So here they have given the one resistance network. We have to find the equivalent resistance. The equivalent resistance between the terminals AB is dash ohms. Okay. So let me solve the problem. Again I have drawn the circuit. See here. Now we will solve the problem. So here observe the network. Observe this middle network. This 3 ohms and 6 ohms are in parallel condition because N to N point are connected here. N to N point are connected here. So this 3 ohms and 6 ohms are in parallel condition. This 3 and 6 ohms are in parallel condition. And here again like that, this 6 ohms and this 3 ohms are in parallel condition because N to N point connections are there. So this is in parallel. Okay. And this 1 ohms and this 1 ohms are in series. So after rearrangement, the circuit becomes 1 ohms, okay, and here again this one, so this is AB, 1 ohms, 0.8 ohms. So here after rearrangement, this 3 ohms and 6 ohms. Again for this network, this is 3 ohms, 6 ohms, and here 1 ohms and 1 ohms are in series, that is 2 ohms, 2 ohms. Okay, 1 plus 1 equal to 2. So now we will find the parallel connection equivalent. So here 3 into 6 by 3 plus 6. 3 into 6 by 3 plus 6 is 18 by 9, which is 2. So after rearrangement this will become So this is 2, this is 2, this is 2. AB 1 ohms, 0.8 ohms, and here equivalent of this two resistance is 2 ohms, and here for this parallel condition 2 ohms, and here this is rearranged here, transformed here 2 ohms. So again this is in the parallel condition. So parallel condition 2 into 2 by 2 plus 2, which is equal to 4 by 4, 1 ohms. So the circuit become 1 ohms. Again 1 ohms in series with 2 ohms, that will become 3 ohms. Okay, so after rearrangement this circuit will become here 3 ohms and here this full rearrangement. Okay, 2 ohms in parallel with 2 ohms plus series. So for parallel condition it will become 1 ohm, 1 plus 2, that is 3 ohms, and this is 1 ohms, 0.8 ohms, and here 2 ohms. Okay, again this 2 ohms and 3 ohms are in parallel condition, so that will become that will become 2 into 3 by 2 plus 3, which is 6 by 5, that is equal to 1.2 ohms. So here 0.8 ohms and here 1 ohms. So we can find the equivalent resistance. So what is the equivalent resistance? Here all are in series condition. So equivalent resistance of this between AB terminals is 1 plus 0.8 plus 1.2. So 2 plus 1, 3 ohms, or equal to 3 ohms. That is the answer for the given network. Thank you.